All right, and thanks for joining me on this Friday. I'm dressed a little bit down now, so a little bit of casual Friday, I guess. Either way, I'm wearing my Warriors shirt. Eat, sleep, be a warrior. Now, just don't do all of those things at school. So let's go ahead and get started with our lesson today. I'm going to go over maybe 6 of them. That way, it still covers enough of it, but we also get the main portion of the lesson covered. So move that out of the way. So again, we're working on word problems. So by the end of this, you'll be able to solve word problems using the strategies I'm giving you. Apply mathematics to real world problems. Some of these are real world. Solve equations using the property of equality and inverse operations. So those are some of the things that we're going to be doing today. Oops. Okay. So here are some steps. I always get students every time, every school year, every place I go, there's always somebody that says something along the lines of, I'm really good at math, but I can't do word problems. So let me ask you, and if I was talking to older people too, like at the college level, you get like people in their 30s and 40s, and I ask them, when was the last time you were walking down the road and you see a nice equation that you just have to solve? It's got little tiny operators like pluses and minuses and stuff like that, and you just solved it. Never. That never happens in real life. If you want to use math in real life, you've got to look for the opportunities to apply it. You're never just going to see, again, a nice little equation or an expression that you have to work on. No, all that stuff, you have to do it yourself. So if you're running into a problem, you've got to work on these steps here. So the first one is familiarize. Now this is my work. You won't find this in very many other places, but these are the steps that I outline to work on word problems. Because a lot of times with word problems, the worst part is trying to figure out what to do. That's usually the first step. Okay, assuming that you can get past the first step, well, actually the real first step would be something like deciding that you want to work on it. Because I know a lot of students, they see the word problem and they're just like, I'm going to skip it, and then you never get it done. But anyway, so again, you got to ask yourself, what do they want? And there's usually clues you can find in the statements to find out what exactly they want. The next thing is to translate. So take those numbers, take your, what you're looking for. So they give you certain things that I call elements. You take those elements and you take those numbers and you put them in a way that makes sense. All right, and usually it's an equation, sometimes it can be an expression, and then you solve it. Find the value of what you are looking for. So again, there's something missing, so it's like a mystery. You are missing something, and now you are looking for it. So how do you find it? Using what they give you. And for the fourth step here, I have, does it make sense? Now, with some of these problems we're going to be doing today, this doesn't work out because in order for something to make sense, you have to, you have to kind of know what it is. Like, for instance, if somebody says, you add this many cups of water to that many cups of water, how many, gallons do you have or something? If you at least can draw a picture in your mind about what the answer would look like, that kind of helps out. If you have a problem and you're pretty sure you set it up right, you can always plug it in and see if it works. That's usually how you check your algebra. And lastly, state your answer in given units. So on some of these, there are no units, so we're just going to have to just try our best to say what these things are. So I'm going to go into more about familiarization. So again, these are not in the notes. These are all my own work. And pretty much every time we have a word problem chapter, I'm going to go over these steps again. So again, you're stuck on a problem. You just barely started it and you just have no clue how to even begin the problem. So there are a couple of things you can do. You can draw a picture. So one of these questions from the work is, the length of a rectangle is more than 4 times its width. The perimeter of the rectangle is 62 meters. So find the find the dimensions. So in a problem like that, you might just draw a basic rectangle. And I'll show you some other ways you can draw a diagram without actually having to be a really good drawer, artist, whatever you want to call it. Well, you're not really creating art because art is supposed to be like inspiring and make you feel things. So a drafter. Anyway, make a list of what you are trying to find. So every problem has something you're looking for. All right, that's the whole reason why you're there, is because you're looking for something that's missing. So make a list of what they give you and think about it. How can you use what they give you to find what you're looking for? And that's this part here. One thing you can do is estimate. So if you have a problem with fractions, you know, if someone says something like a 1 3/4 cup plus of one ingredient and a, 3.25 cups of another ingredient, just round them off and read it again. Again, this is to help you figure out what kind of problem you're up against. Just round off the values, ignore the fraction, and see if it makes more sense. And lastly, this is a strategy I don't usually like, but it works plenty of times, especially with high school level word problems. Underline keywords. So I'm going to go ahead and tell you some of these keywords. So you might want to take a screenshot of some of these. Ooh, well, I already have some of them underlined. Those underlined ones are the ones that are a little bit more important because they're trickier. They are different. So most of these you already know. Like if I asked you to think of some words that mean addition, increased, more than, combined, together, total, sum, plus, added. Those are no problem. Okay, everybody knows those. So these ones I underlined in orange are tricky. Those ones are often confused with each other. And the ones I underlined in purple, sum, difference, product, and quotient, are grouped. All right, so when you see those words, it means do those first. So easiest way to translate that is into parentheses. So when you see something like that, it means you are looking at a parenthesis of that operation. So like if I say the difference of 7 and a number, that means 7 minus like x or something like that. But again, it's going to be in parentheses, so you have to do that first. And the other confusing one is less than. So if you see something that says less than, some people might think, oh, you're talking about that thing that has a little mouth that opens towards the bigger number. Yes, that is true. Inequalities do have the word less than and greater than, or sometimes they have the or equal to on them. But in this case here, if we're talking about pure algebra, there is no is. So if it says is less than, okay, so is also the equal sign too. If you look here, well, maybe I'm going to change the color on that too. But if you see the word is, are, was, were, will be, gives, yields, those mean equals. And I think a lot of teachers, a lot of books don't mention this part, is the equal sign is an operator as well. It is an operation symbol. But again, less than is the only tricky one because it's the only one that is backwards from the way you would read it. So let's go ahead and I'm going to move on, and I'm going to kind of go through some of these. I think for this first one, I am just going to set it up. Oh shoot, did I think I left some of these on from the last class. I didn't clear them up. Oh well, so I guess on some of these it's not. Oh, gosh. All right, so let's go ahead and just again set it up. You're going to have to solve the rest of this one on your own. So the product of 7 and a number. So product again means multiply. So 7 times a number. So I'm going to put 7 in. That's how we say that. So again, that means we add it first. So, or sorry, multiply it first. Then we add it to say increased by 3 is equal to. So in this case, they just tell us straight up, there is an equal sign, is equal to twice the number. So twice the number subtracted from 39. Now, if you're reading this in order, so twice the number subtracted from 39, this is what you might write. But that's not right because it says subtracted from 39. So this actually means, again, 39, and we're going to subtract twice that number from it. Now, for some people, that might have sounded a little bit weird, okay? And in that case, if you did, then you're right, it was weird. Because, again, with some of these subtraction ones, they're backwards. So they're going to pull some tricks on you. Okay. So I'm going to look for another one. I'm sort of just going over some of these that are pretty, and again, I think they're going to be pretty difficult. So with that one, you can go ahead and just work on the algebra yourself, and it should be pretty easy. So I'm going to skip over to number 3. One number is 9 more than twice another number. If the sum of the numbers is 129, find both numbers. So in this case here, if we look at the question statement, because again, remember, that's the first step. Familiarize yourself. What do they want to know? Well, they definitely are asking you what they want to know, and that is both numbers. So this is a clue that we're not looking for one thing, we're actually looking for two things. And kind of like with drawing a diagram, this is kind of what I do. I find it kind of helps, is that again, we're looking for two numbers. So one number, I'm going to just put a bracket, you can underline it or something, but I usually put the line on top, and then I put these kind of like quotation things. This tells you that this is number 1 and number 2. So there's two numbers. We don't know what these numbers are yet, but we know that if we add them, because it says here the sum, if I add them together, we get 129. Again, the sum means result of adding. So if we add the first number, the second number, we get 129. So let's go ahead and start filling in what we have. So it says here, one number is 9 more than twice another. And again, be careful with is, because in this case, is not the equal sign. 9 more, so 9 plus twice another number. So we get 2n plus 9, or 9 plus 2n. It doesn't really matter. You could write it either way. But it says here that there's another number that we're missing. So that is probably the same number. And there we go, we set it up. Now let's look for the first number. So with these kind of word problems where you're looking for multiple items, we're looking for multiple variables, you want to decide which one is the most important one to find first. The most important one is going to be the first one in this case here, because if I know what the first number is, I just double it and add 9, and now I have both numbers. So let's go ahead and solve it for the first number. So n plus 2n is 3n. And I'm also going to minus 9 from both sides too. So minus 9, so 129 minus 9, going to be 120. Divide both sides by 3. And again, this is just basic algebra. I'm sure most of you guys at this level know it. It's just the setting up part is, I think, the part that I'm going to focus on today. So n is equal to 40. The number is 40, so we're done, right? Again, be careful with this one, because if we read the question again, it says find both numbers. So I could plug it back into the equation, but that would only allow me to check it. For this one here, I'm going to have to use the other clue. So again, number 1 plus number 2 equals 129. And I'm looking for the second number. I know the first number is 40, right? 40 plus this number, we'll call this one number 2, or number n sub 2. Okay, but that's probably distracting. Let's leave that n off for now. So what number can I add to 40 to get 129? Well, if I minus 40 from both sides, n equals 89. And that's our second number. So the number 1, the first number is 40, and the second number is 89. And if we check it, 40 times 2 is 80. 80 plus 9 is 89. So we checked it twice, and it works both. It works both in both sets that we checked it in. So there we go. We have both numbers. So again, sometimes they are asking for two things. And I'm going to go into number 4. Number 5 and 6 are kind of the same thing. And I know some of these word problems on the packet are a little bit, you know, they will be really challenging. And looking at them, yeah, it is a big challenge on some of these. In fact, with my morning class, I had somebody correct me, and I think it was actually this problem right here, number 4. So 2 people are playing golf. Well, there probably were more, but these are the 2 people we are focusing on right now. So Kara had a golf score that was 1 less than 3/4 of Greg's score. If the sum of their scores is 153, find Kara's golf score. So again, that's our. One thing I forgot to mention is word problems are usually structured in a certain way. They're not always this way. Sometimes people will throw a curveball, books, textbooks, or whatever will throw you a curveball. But it's kind of like English papers. There's an introduction. So in this case here, it's telling us that there was a golf score, or sometimes they'll introduce what's happening. But in this case here, just by the clue statements, which is the next part, is the clue statements. That's the second part, and the clue statements tell us that there's a golf game going on, so we don't need to worry about that. And the third part is usually the question, and the question is you kind of have to read it a little bit backwards. You have to start with the last thing. So again, we're looking for Kara's golf score in this case. So Kara plus Greg, and I'm just going to use their letters of their names. And we know that if we add them together, we get 153. Now again, this part here was a little bit of a trick because I had to really look at this and think to myself, let's see, Kara's golf score was 1 less than 3/4 of Greg's score. So this means that we are comparing Kara to Greg. Ooh, excuse me. So in this case here, Greg is the first one we should look for. I will assign the letter X to Greg. Now again, whatever Greg got, Kara is 1 less than 3/4. So take Greg's score, times it by 3/4, and lessen it by 1. And again, this one is one of those tricky ones because a lot of people reading this would say less than. Is it those little mouth thingies? Yeah, those things do mean less than also, but in this case, we're talking about subtracting. So again, if we take 3/4 of Greg's score and minus 1, that will be Kara's score. Now it's set up. We can go ahead and start working with it. In this case here, we are going to be dealing with those things, fractions. And this one's a tough one too, because this is one of those ones that uses a lot of fractions. So how do we go about this is the question I'm going to ask, because I mean, we could use mixed numbers, or we could also just, I don't know. But I'm just gonna do it the same way I did it with my morning classes. So add 1 to both sides, and let's go ahead and combine our X values at the same time. So in this case, I would get 1 3/4, but I'm going to put a 4/4 here because remember, if you see a variable, the number in front of it is 1. And if we use the property of division where you have a number divided by that number, it's still equal to 1. So in this case here, I have 7/4 because 4 plus 3 is 7, my top number. Bottom number 4 is still, well, 4. It doesn't change. Remember, bottom numbers don't change. And here I have 154. Now, I need to get rid of this. So I wasn't sure if you guys were ready for this, but yesterday I went over a shortcut. I mentioned it, but I didn't say what exactly it was. And that is multiplying it times the reciprocal. And there are many different ways to do this. With this particular problem, you probably could use a calculator and just round it off with a decimal. So instead of 7 over 4, you might say something like 1.75. And you could divide 54 divided by 1.75 or something like that. Now in this case here, I'm going to multiply 154 by 4. 154 plus, times 4 is going to be, I should have brought my own calculator out. 4 times 4 is 16, carried over. 4 times 15 is 60. 60 plus 1 is 616. Okay, there we go. I don't know why I sweated that one. Now, what happens to this side? Oh, we're still dividing it by 7. But on this side, focusing on this side here, why did we times it by the reciprocal? Well, 4 times 7 is 28. 7 times 4 is also 28, so I get 28 over 28. And 28 over 28 is just equal to 1, so that's x. Now I am going to divide 616 by 7, and I get 88. And we're done. Whew, that was easy. Okay, if you've ever watched horror movies, you know sometimes you're just not done. This is Greg's score. Remember, the x by itself is Greg's score. So, and looking at it, it looks like Kara's score was less because it's 3/4 of it. So it's going to be a little bit less than 88. So we still have to find it. But again, we have another clue. If we add Kara's score, so I'm going to put K for Kara, and Greg is 88 because we know that's that was his score. Come to think of it, you know, I have no clue how golf is scored. I know they have like par, like how many swings you're supposed to actually take, and you want to be under par. I don't know. The rules were described to me once, but I never actually. I don't remember them. But it has something to do with how many swings you take, and lower is better. Anyway, 88. It's supposed to be 88. So Kara equals 65 if we subtract them. So there we go. Now again, we're looking for Kara's score, not Greg's. So this is our real answer here. But again, I'm picking some of these ones that are the most tricky. A lot of the other ones are not as tricky as this one. I'm really doing the toughest ones that I can find, although there are quite a lot of tough ones in this one. Oh man. Okay. Oh, there you go. That's good. Whew. All right, I'm going to jump over to number 8 now. So I think 8 is this one, and I'm going to have to clear this slide. I didn't clear it from the last class, so let me go ahead and just push that before you see anything. There you go. And again, this one's a really tricky one. When I saw this one, because one of my students had actually tried this before he came to the class, and he goes, "Can you go over number 8?" And I'm like, "Okay, let's do that." And we started on it, and I'm just like, "Oh my goodness!" So I didn't write these questions. I got a curriculum that was given to me, and this was one of the problems that was on there. So if it were up to me, I probably would have gotten some easier word problems and word problems that would have maybe applied a little bit more to real life, you know, because nobody buys 73 watermelons and stuff like that. You know, I've seen all the memes. So with this one here, we have 3 people. We have Kelly, Laura and Tia. And they sold boxes of cookies for a fundraiser. So there you go. That's our introduction statement. They're telling us what's happening. Boxes of cookies are being sold. Now, our first clue statement says, Tia sold boxes of cookie. Oh, wait. Sorry, I meant to start here. My eye left here and I didn't come back to write exactly where I was. So sorry. First clue statement is Kelly sold 15 boxes less than Laura. So we don't know how much they sold. This 15 doesn't mean that she sold 15 boxes. She sold 15 less than Laura. So if we know what Laura sold, we minus 15 and that's how we get Kelly's. And the second clue statement is Tia sold twice as many boxes as Kelly. So if we know what Kelly sold, we double that, and that's what Tia sold. And we have one last clue statement. If they sold 83 boxes in total, then how many did each girl sell? So that last one is our question statement. So that's what they want to know, you know, because they could ask anything. They could ask, how much did one person sell? A specific person. But in this case, we want all three people's number of boxes sold. So let's do the same thing. I'm going to go ahead and write out the letter of each name. So K, L, and T. And we're going to start filling this up as much as we can. So again, there's three numbers. So let's go to our clue statements. Kelly sold 15 boxes less than Laura. So like I said, if we know what Laura sold, we will know what Kelly sold. If we know what Kelly sold, we will know what Tia sold. So in this case, the most important person to figure out first is Laura. So we will assign her the value of, I don't know, let's pick a letter. I don't like picking X all the time because it's like X is just so overused. And I don't know if I really consider X to be an alphabetical letter, because how many words do you know that have the letter X in it? Anyway, I'll continue that in a bit. So again, Laura is the most important person right now. And if we know what Laura sold, we will know what Kelly sold, because Kelly, and again, you have to compare it to Laura, because if Laura sold X number, we take that X minus 15, and that is what Kelly sold. So just as an example, let's say that Laura sold 20, then Kelly would have sold 5. There you go. And oh, one other thing I forgot to kind of point out too, whenever you do these kind of problems, you pick one thing to do. I'm not sure if I made that part clear. You pick one element of who to find first or what to find first, and you focus on that one element. Everything is compared to that one piece. In this case, it's Laura. And here I have T. So T is, let's see, Tia sold twice as many boxes as Kelly. Now, we don't know what Kelly sold. The only clue we have is Laura minus 15. But we need to double this number somehow. So to double it, we have to use our distributive property. Oopsie. Use our distributive property. And we have 30, right? 2x minus 30. Because we got to double it. And again, this one's kind of a messy one. I have a very similar problem like this in my college class. And at the end of the year, I'll usually try to give a small prize to whoever solves it. And actually in the like 9 or 10 years I've been there, I've only had maybe 3 people. So like, I usually have about 40 students a year, twice a year. So that's 80 times 10. So I've probably had about 800 students. Now, some of them were the same student who retook the course. So realistically, you're looking at about 500 students that actually got to that point in the course. And only 3 of them actually figured out a problem similar to this one. So don't feel too bad, okay? But it's set up now. So let's go ahead and use our algebra skills. 1, 2, 4, so 4x, if I put all the x's together. minus and negative 30, negative 45, and I get negative 45 equals, and it says here, again, they sold 83 boxes, which I should have pointed out right here. So if we add all three of these people up together, we have 83 boxes. Now, we still got to isolate our variable because we're still looking for what Laura sold. That's what we want to know. 4x equals, and then 5 plus 3 is 8. And we have 4 times, if we quadruple what Laura sold, we would have 128. So what number times 4 equals 128? So in this case, it would be 32. I ran out of space right there. I would put a 4 under both of these numbers, but I didn't. I wrote a little bit bigger. So, but anyway, we have our first clue. Our first element. So Laura is 32 boxes sold. And from here, it gets a little bit easier because remember what I told you at the beginning. If we know one person, in this case, the most important person to know how many they sold, it's Laura, because if we know what she sold, Kelly sold, what is it here? Kelly sold 15 boxes less. So let's lessen that by 15. 32 minus 15 is 17. And lastly, we have Tia, which says here she sold twice as many boxes as Kelly. Twice as many boxes, so double 17, you have 34. And let's check it. 7, 9, 13, so 13, carry the 1. So there's a 3 down here. 1, 2, 2 plus 6 is 8, so that is 83. So we checked it, it worked out. We added all these numbers together, and we know that we got each of these numbers from the same source. Again, starting from Laura, we know what Kelly sold, and once we know what Kelly sold, we know what Tia sold. So again, this one's, yeah, this one is a big challenge of a problem. So I wish I could say there was an easier way to do this, but this is how it has to be. Okay, so we did, how many did we do? Okay, I think we did 2 on the first page. So that would mean that we'd have to do, okay, so let me just go back and count them. 1, well, we technically got the first one started. 1, 2, 3, 4. Okay, so let's do another one. One of the other ones I had asked to do was number 12. So this one's very similar, but this one also introduces a lot of vocabulary that some people may not be familiar with. So we need to find 3 consecutive integers such that the sum of the smallest integer and twice the median integer is 20 more than the largest integer. Even reading that was confusing, but let's take it apart piece by piece. So we have our introduction, find 3 consecutive integers, 3 consecutive even integers. So in this case, consecutive means one after the other. So last week, or was it sometime earlier this week, I made a joke. I made a joke saying that, I'm just gonna skip my next birthday and be the next age. Okay, you can't do that, right? So consecutive means it has to be the next one. They go one after the other. So in other words, we can't skip any. And these are even numbers, so that kind of adds even more complication to this. So there are 3 numbers, 1, 2, 3. And like I said, this is a drawing diagram. So this fits under the the strategy of drawing. So we could assign more variables, but it's going to get really confusing if we keep assigning more and more variables. So I'm trying to keep the number of variables down. So again, one number, two number, three number, and if we add, well, it doesn't really say if we add them all up or anything because it doesn't tell us anything. So we're just going to have to kind of work from there with what we have. So let's go ahead and work with the first number. So the sum of the smallest integer and twice the median is 20 more than the largest. So let's go with the introduction statement. Find 3 consecutive even integers. Now this means, like, if I started at 2, it would mean the numbers would be 2, 4, and 6. If I started at, let's say 16, the consecutive numbers after 16, even numbers, would be 16, 18, 20. So every time we have a number, we are adding 2 to that number. So plus 2. And this one's a little bit of a tricky one because starting from the first number, we would have to add 4 to that in order to get the third number. So again, if the first number was 2, the third number would have to be 6. If the first number was 16, the third number would have to be 20. So again, we're adding 4 to it. So that's the pattern. Now we need to plug this in. So we're focusing on this. That's our primary element. That is the thing we are looking for, because once we know the first one, we should be able to figure out the other two pretty easily. So let's go ahead and keep going with this, such that the sum of the smallest integer, so the smallest integer, so this number here, and twice the median, so twice the median, so double the middle number, so median means middle number, twice the median is, where did it say that, is 20 more than the largest integer. Now again, this is means equal, so that part is you know, if I didn't point that out to most people, they wouldn't have caught that. But that is means equal, and 20 more than means plus the largest integer. So that would mean my largest number was x plus 4. Whew. Okay. Yeah, that was a bit of an exercise for me too. Okay. Let's use our algebra and see if we can get this solved. So first thing we got to do, as always, is get rid of these parentheses. So I'm going to distribute to both of those numbers, combine our like terms. So 20 and 4 are both like terms, so I'm going to put them together as 24. And now I should probably also combine these numbers too, because we still have more stuff to combine. 3x plus 4 equals 24 plus x. And as always, I need to pick a side for the variables to go on. So I can either put them on the left or put them on the right. So minus x from both sides. And again, we're going to do the trade, the old trade. If this side gives up something, this side will also have to give up something. Since I'm moving the x to the left side, I'm going to move my regular numbers to the right. So to get rid of this positive 4, I'm going to minus 4 from both sides. Now I'm gonna re-put this up here because I'm out of space. 3x minus x is 2x. 4 minus 4 is 0, so we have nothing left there. And 24 minus 4 is 20. So there you go. I got all my regular numbers on one side and my variable on the other. But we're still not quite done. Divide both sides by 2, and that will give us the first number, which is 10. Right around this time of the day, I always get that feeling that somebody's walking on the roof, which is why I don't usually do this for my third hour, but I don't know what it is. It's like the same time every single time of the day. I don't know if it's like a vent or something, or probably just ghosts. Anyway, I'll have to get some ghost spray on the way home. All right, so again, we have the first number. And by that, we should have the next number. So the numbers are 10, 12, because they're consecutive and even. And this is the last one, 10, 12, and 14. So those are the three numbers that we were looking for. 10, 12, and 14. Whew. I don't know if you guys feel like another one. We could do another one. Let me just, where's that packet that I had earlier? Yeah, like I said, I had a student in my first hour who tried these, and there were some that he just couldn't figure out. I mean, those are the ones that I picked now. Which one? Let me see if there's one that we might have to go over. So I tried to pick one that used every trick. So I tried to pick one with fractions, one where we had to check it, one where we have, and two where we have 3 elements. Let's see, the length of a trapezoid is 5 times less than the other base. I'm gonna try number 6, I guess. So with number 6, it's a trapezoid, so I'm not sure if it'll help us, but I haven't worked on that one at all this morning, so that might be a good one because I haven't, oh, there it is, trapezoid. So the base of one trapezoid is less than 5 times the length of the other base. So a trapezoid, and this is the reason why I wanted to go over this one, because I think a lot of people don't know what a trapezoid is. A trapezoid is a shape that is a quadrilateral. It has 4 sides. One set of sides is parallel. So we usually put these little arrows here to indicate that they are parallel. And you have 2 sides, you know, sometimes they usually when you see them, they're kind of the same angle, same side, size, length, whatever you want to call it on the sides. But in this case here, we are going to have a shape like this. So the length of one base is 19 less than 5 times the other base. Darn, I don't even know. Okay, so which one of these is likeliest to be the short one? If the trapezoid has a height of 18 feet and an area of 477 feet. So let's go ahead and just work on that one. So the height refers to all the way down and all the way to the top. If you were to draw a right angle from here to there. So that would be 18. And it looks like we are going to need the formula for a trapezoid. Now, this is one of the things that I missed on the familiarize. So on the familiarize step of this, one of the things that you may need is a formula. Now in this case, I know the formula of the area of a trapezoid. So it says area, so again, that's a keyword. And it doesn't tell us everything we need to know because this formula, we have to either know it or look it up. So it is base 1 plus base 2 divided by 2 times the height. Now let's start filling in what we know. So area is 477. I'm going to reverse it. I'm going to use reflexive property just to keep the variables I'm looking for on one side. So let's go ahead and do that. So base is 1 plus, so that's this base here. And I don't know which one I'm looking for, but in this case, it'll probably work out no matter what if I just follow what I'm supposed to do. 19 less, so minus 19. So we're taking this number and we're lessening it by 19. So again, it's not 19 minus the number. It's 5 times the number. So 5 times the number, and we are going to lessen it by 19 to the other base. So in this case, it looks like we're looking for the top number here. This top line is the one we're looking for. And this bottom one is the one that we'll find second. And it says to, oh yeah, I forgot to read this line here. So it says it wants to find the length of the longer base. So this is the one here. This is the main one we're looking for. So let me go ahead and fit that in. So let me just double check. The length of one base of the trapezoid is 19 less than 5 times the length of the other one. 5 times minus 19 equals the area, which is 477 feet square. Now I'm going to have to get rid of this fraction, just like we did yesterday. If you have a fraction on your work, I'm going to double both sides. Now by doubling it, remember this bottom 2 here means to divide it by 2. So by doing the opposite and timesing it by 2, they cancel each other out. And that makes my bottom number 1, which in a fraction, if at any time your bottom number becomes 1, it just becomes whatever's on top. Or again, they just cancel out. That's the way most teachers would explain it. B plus 5b is 6b minus 19. And in this case, I'm going to have to do 477 minus 2. Okay, 14 carry over. Now it's a buzzing noise. All right, 14, so 2 times 7 is also 14. 14 plus 1 is 5. I'm sorry, 15. And 2 times 4 is 8, so this would be 954. That seems about right. Now I'm going to add 19 to both sides, so plus 19 plus 19. 6b equals 954 plus 19. So 9 plus 4 is 13, carry the 1, and that would be 7. So 973. Divide both sides by 6. Let me grab a calculator for this one here. Just use my pocket calculator. Okay, now this is not quite adding up. Like I said, I didn't work on this one before, but something seems way off. Divided by...
Mr. Nez, you didn't multiply the height.
Yeah, okay. Oh, man. Okay, I knew something was off. I'm looking at it and I'm like, okay, something is definitely off.
Me too. That's where I was at too with those numbers. And I was like, what the heck?
Oh boy. Okay. Gosh, I just messed up that whole thing. Let's go ahead and try that again. But again, that's a good lesson, because if you remember, one of the things that I told you to do is check it and make sure it seems right, because I call it the sniff test. You know, like when you're working on like a cooking something and something doesn't smell right, that's usually because something horrible happened. And this is a pretty good lesson. Like I said, I haven't worked this one out before, but I know that it sounds really weird, that something just doesn't match up. And this is something that happens to everybody. But, you know, the difference between somebody who gets it wrong and the person who gets it right is not who's the smartest person who doesn't make mistakes, but it's oftentimes the person who catches their own mistakes. So in this case, something didn't seem right, and I knew that. So let's go ahead and start from the equation, start back from the beginning. I could double everything, but I think I'm gonna have to go with 18. I'm gonna divide both sides by 18, which is gonna look something like this. And now I get 477 divided by 18. 477 divided by 18. And that's going to be 26.5. Because again, remember, to get rid of it, we have to do the opposite. Since it's times 18, I'm going to divide by 18. So in this case, I get 6b plus 19 over 2. Now I'm going to double both sides. Double both sides, and that'll cancel this out. Now I have 6b plus 19 equals, and double 26.2. I'm not going to leave this one to chance now. It's going to be 53 minus 19 on both sides. 6b equals, and 53 plus 19, 72. Now this seems a lot more reasonable. All right, because in that last one, I would have had one side that was like 100 something units long. And that doesn't seem very likely, you know, again, it just didn't seem likely. And 72 divided by 6. Now this seems a lot more plausible, 12. Because if one is 12, right, I have to plug that back into the other one. So the length of one side is 19 less than 5 times the length of the other one. So take 5, and we use this one here. So 5 times 12, add 19. So 5 times 12, wait, hold on, is 19 less. Oh, so we got a less in it. So that means minus. 5 times 12 is 60 minus 19, which is 41. Whew, okay. And there we go. And again, we're looking for the longer side. So if 12 was the short side, 41 is the long side. Yeah, okay. So, you know, again, everybody makes mistakes. Nobody's perfect. You know, you got to remember how many times NASA lost spaceships because somebody didn't do their math right. So makes me feel not so bad anymore. Okay. Well, that lasted a bit longer than I would have thought a Friday lesson would last. But anyway, that's going to be it for today, I think. So like I said, don't worry about this one too much. These problems are pretty advanced, as you've seen. You know, it gave me a challenge.
Mm-hmm.
So
For sure.
yeah, and some of these, a lot of these are like this too. You know, I mean, I couldn't, I wish I could go over all of them because they're all pretty tough, but it's only extra credit. So if you don't want to do it at all, you know, just fill in the ones we went over here, and that should be good enough for the lesson. For just to get the work done. Anyway, that's it for today. I don't think there's anything else. If anyone else has any more questions or anything like that, I think that means we are done, right? So any other questions? Oh, and I'll also take any questions you have from the from any other lessons from any time this week. So I did have a couple of students this morning asking questions about like homework from the beginning of this week. So if you're almost done with your packet, but you're just short, you know, a few questions, we can go over those. Because now's your chance to ask questions if you got any of them. And like I said, it can be from anything. I don't think you can go to the school anymore. The gate is closed all day, I think. The packets used to be that parents could pick them up whenever, but they changed that rule now, so you can't change, or you can't just pick up the packet. They have to be mailed out now. So I don't know why they changed that. And I don't think they even told me. In fact, the students yesterday figured that out one before me, because I said, one of the students yesterday says, I didn't get my packet from last week. And I'm like, really? You should have gotten it last week. And they were like, well, they're not giving them out at the school anymore, so we can't just pick them up. So I was like, okay. Now they're emailing. They're mailing them all out by postal service. How do I turn in my packet? Just bring it to the school, and there's a big box out front. I think you still have to bring them in, but I don't think they're going to let you pick them up. Maybe if you, like, I don't know, ask for it really nicely, they might give it to you. But again, turning them in is, as far as I know, you just bring it back. But again, I don't know why they don't just give it to you, because it would make sense that if you're already there dropping it off, you should be able to pick your next one up. And my packets were ready on Wednesday, which was 2 days ago. So if mine were ready 2 days ago, then there's no reason they shouldn't have given them to you. Anyway, but no questions about any of the work though? All right, well, anyway, I guess that'll be it for today's lesson. So I will see you next time. Haha, it was me. I was here all along. I should have just stopped it right there.